Okay, so what we're going to be talking about today is how to do trigonometry word problems. And it's going to be word problems that only involve right angles because those are, of course, the only ones that we know how to do. So before we start, we're going to have two concepts. So the first one is going to be called the angle of elevation. So that's our first concept. So the angle of elevation is, imagine you are, there's some dude. I'm going to do some beautiful art here. And the dude is looking at a balloon, hot air balloon, hovering in the air with the basket. So what happens is, that's the line of sight. So the dude is looking at the balloon. This is the straight. That's the angle of sight. So that's the horizontal line and the angle of sight. And then the angle between these things is called the angle of elevation. So the angle of elevation is between the horizontal line and looking up at the balloon. And the other word we're going to have is going to be something called the angle of depression, which sounds like sadness, but it's not sadness. Depression is more like a, or maybe you've heard of a depression in the ground. It's going down. So let's say it's opposite. So what happens is you have an airplane. And the airplane is looking at, I don't know, it's looking at a pot of gold on the, or a house, we'll just say a house. An airplane is looking at the house on the ground. And what we have is, again, we're going to have that kind of line of sight, that kind of diagonal line of sight. But again, it's going to be the angle between the horizontal and the line of sight. The thing is, there's no horizontal here. So what you actually have to do, often for angle of depression, is you have to kind of create a horizontal. So horizontal is a horizontal line. So it's a horizontal. There's a line of sight. A horizontal line of sight. And again, it's going to be the angle between the horizontal and the line of sight. And this over here is going to be called the angle of depression. So it's looking straight. It's like starting off straight, the angle between looking straight and then looking down. It's tempting, you'll see in a lot of problems, it's tempting to call this the angle of depression, but that would not be true. That would be incorrect. So the angle of elevation is between the horizontal and the line of sight. The angle of depression is between the horizontal and the line of sight. So now we have that. We're going to do a couple problems. So let's say, example 1. Mackenzie is out flying a kite. The string is 35 meters long and makes an angle 50 degrees with the ground. How high is the kite above the ground? So, one thing I should mention, actually, before we go too much forward, we're going to make some assumptions here. We're going to say that people, trees, buildings, flagpoles, and other cliffs, and other such things, we're going to assume that they are OS vertical. So they're OS vertical. So what that means is that if I say there's a flagpole, we could safely assume, if we have a flagpole, we could safely assume that the flagpole is vertical and the angle between the flagpole and the ground is 90 degrees. We'll never have a situation where the flagpole is falling, unless it actually says so. So if the problem says a flagpole is fallen over and crashed into a house, then clearly it is this and not this. But unless it says otherwise, you could assume that people, trees, buildings, cliffs, flagpoles are all vertical. So here we have, our goal for all these things is going to be to draw a right angle triangle. If we could draw a right angle triangle and put the right numbers on, it's going to be fairly easy to solve. So, and you could draw it in a very pretty way, but you don't have to. So if you want, you could kind of say, okay, here's Mackenzie, and she has the kite, and there's the string. Okay, I don't really know how to draw, so there's kites and then there's the string, but there we go. So the string is 35 meters long. So that's the string because she's holding it. So this is going to be 35 meters. It makes an angle of 50 with the ground. So here's the ground, there's the string, so this angle is going to be 50 degrees. Now I could have said that the angle of elevation of the kite was 50 degrees, and that would have been the same thing. The angle of elevation would have been 50 degrees as well. But in this case I explicitly said it was between the string and the ground. And then the question is, how high is the kite above the ground? So the height of the kite above the ground is this thing over here, and that's the one we don't know. So we're going to call that an x. And now we're ready. So we have everything. So this is our angle. So this is our opposite side. This is our hypotenuse. This is the adjacent. We're going to SOHCAHTOA this thing. SOHCAHTOA. So we are looking for an opposite. We have a hypotenuse. We want something that involves opposite and hypotenuse. That's going to be sine. So we're going to have sine of 50 equals x over 35. And hopefully you've done a couple of these sheets by now so you know how to solve it. Oop, no, I don't cross that out, I cross these guys out. So x equals 35 sine 50. I take our calculator, remembering it has to be in degrees. If you're not sure if you're in degrees, say that the sine of, type in the sine of 30 and it should say 0.5. If the sine of 30 is not 0.5, your calculator is not in degrees. You need to change it to degrees, which means either look for a reset button or go online and figure out how to reset your calculator or how to change the degrees. My calculator is in degrees, this we could go. So it's going to be 35 times the sine of 50, which is going to be 26.8. So it's going to be 26.8. Now this is a word problem though, so we would have to then finish this off by saying, therefore, the kite is 26.8 meters above the ground. And that's how we do the first question. Okay. Example 2. So we're going to say an ice storm caused a 13.5 meter hydropole to lean over. Okay, so remember just before I said that poles are always vertical? Well, here's a situation where it's not because the problem says it's not. The top of the pole is 11.8 meters above the ground. Find the angle between the hydropole and the ground. Okay, so we're going to start this by drawing a right angle triangle. So what we have is this thing over here, this is the pole, right? What we have, that means if I was gonna draw it, it would probably look something like, here's the hydropole with the wires, and there's the ground. The hydropole is leaning over. So these lines don't necessarily exist, but that's the hydropole leaning over. So an ice storm caused a 13.5 meter hydropole. So this hydropole measures 13.5 meters. And the top of the pole is 11.8 meters above the ground. And I want the angle between the hydropole and the ground. So I'm looking for this angle over here. So I'm going to call that x. So if that's x, then this is going to be opposite, hypotenuse, adjacent. Again, I want opposite hypotenuse. It's actually sine 1 again. That's a little bit boring. I should have not done that. So it's going to be sine of x equals 11.8 on 13.5. This is one of those find the angle inverse thingies. So x is equal to the inverse sine of 11.8 over 13.5. Inverse sine of 11.8 divided by 13.5. So it's 60.9. 60.9 degrees, which we're going to round to 61 degrees. And of course, it's a word problem, so we're going to have to say, therefore, the angle between pole and ground is 61 degrees. Done. Okay, example 3. We'll do the angle of depression here. While standing on the top of a 350 meter tall cliff, Joshua sees a boat in the aqua below. The angle of depression from Josh to the boat is 36 degrees. And so the question is, how far is the boat from the base of the cliff? So I would pause this to try to draw it yourself, but obviously I wouldn't know either way. So you could do what you want. So what we have is we have our cliff. This thing over here, this is the cliff, which as I said is vertical. And then here we have the water below. So it's kind of wavy, but really we're going to think of it as a straight line. This over here, this is the top of the cliff. And then the bottom is what we're going to call the base of the cliff. And that kind of terminology comes up a lot in these problems too. There could be the top of the tree and the base of the tree. So the base means the bottom. Top of the flagpole, base of the flagpole. Top of the building, base of the building. So top of the cliff, base of the cliff. So we're standing at the top of a 350 meter cliff. So we know that this is 350 meters. Josh sees a boat. And then here's Josh, of course. And there's our line of sight to the boat. And the cliff is at 90 degrees. The angle of depression from Josh to the boat is 36 degrees. Now it's very tempting to call this angle 36 degrees. But remember, the angle of depression has to be between the line of sight and the horizontal line. And so what we need is it has to be between this and a horizontal. So what we're going to have to do is we're going to have to, there's two ways to kind of do this. One way is to say, so this angle is 36. And then we know that this over here is also 350. If this is 350, then that also has to be, whoops. If this is 350, then that also has to be 350. And similarly, this would have to be the same with this. Another way of looking at it, so what you could do is you could kind of work in this triangle over here, or you could work in this triangle over here. We know this is 36, so we could figure out this angle, because we know that this angle has to be, this whole thing is 90, because it's a vertical and a horizontal. This whole thing is 90, so this one has to be 90 minus 36. And 90 minus 36 is 54. So that's going to be 54 degrees. Now either way, we're trying to find how far is the boat from the base of the cliff. So we're trying to find this distance over here. We want the distance from the boat to the base of the cliff, which incidentally would be the same as this distance over here. So you have a choice. You could either work, as I said, in this triangle, or you can work in this triangle. So let's work with, I'll do it with both. So if you're going to do it kind of in the blue triangle, then that's our angle. So this is going to be the opposite. That's going to be the adjacent. This will be the hypotenuse. And we know we want something that has opposite and adjacent. And looking at our SOHCAHTOA, opposite and adjacent is going to be this one over here. So that's our opposite and adjacent. And we're going to have sine of 54 equals x over 350. And then solving it, I'm going to skip a step here, kind of. So 350 times sine 54 is 283. So x is going to be 283.1. Or if we had done it in the red triangle, so we look at the red triangle, then this is our angle, this becomes the opposite, this becomes the adjacent, and we're going to have tangent. Oh, crap, I did this wrong. This should be a tangent, actually. I don't know why I said sine. Tangent of 54 equals x over 350 because it's opposite over adjacent, which means that this is a tangent, which means 350 times the tangent of 54 is 481. This is why I shouldn't make the videos too long, because usually at this point I would have restarted the video, but I'm not going to redo that now. So now over to the red triangle. So that's what it should have been. It should have actually been 481.7. For the red triangle, we're going to have the tangent of 36 equals opposite over adjacent, which is going to be 350 over x. And this is one of the ones with the x on the bottom, which is a little bit trickier. So then what we do is we multiply both sides by x. So x tan 36 equals 350. And then we divide both sides by the tangent of 36. Chunk, chunk. So x equals 350 over the tangent of 36. I apologize for the horrifying handwriting. So 350 divided by tan 36, and hopefully it gives the same answer. And it does. It's 481.7. So either way, the answer is 481.7 meters. And then, of course, we would give a word answer. Therefore, the boat is 481.7 meters away from the bottom of the cliff. And that's trigonometry word problems.